me just start off. Of all the major symbols in literature, art, religion, there's probably not one of those symbols that is more ambiguous and double-edged than fire. For example, fire represents decay because fire purges the soul of sin, and hell refers to the everlasting punishment and torment for an individual's sins. But there's also the story of rebirth when it comes to fire. For example, with the phoenix, this mythical creature dies as a result of fire and spontaneous combustion. However, it then bursts into flames before turning into ash. And from that new ashes, a new phoenix arises. Okay. And if we look at our history as humans, we find that humans have taken advantage of fire for well over 400,000 years. By learning to control this element, we have used it to our advantage when cooking, staying warm, and producing tools that helped us evolve as a species. Now, from a scientific perspective, the only planet where fire can burn is planet Earth. And that is because all the other planets lack sufficient oxygen. Another cool fact about fire is that the flame color is affected by the oxygen supply. However, I'm going to hand it over to the expert. Tercia Strydom completed her honors in environmental and water sciences at UWC, where she investigated ground surface water interaction using a naturally occurring radioactive isotope as a tracer. It's a mouthful. In 2011, she joined Sandparks as a junior scientist and is based in the Kruger National Park. In 2012, she started a master's in hydrology at the University of KwaZulu-Natal. Here, her project focused on the effect of long-term fire treatments on soil hydrology and soil properties in savannas. She just recently started with a PhD in soil sciences at the University of the Free State and is currently employed in the Kruger National Park as a scientist in abiotic processes. And with that, I hand over to you, Tercia. Looking forward to your talk.
Thank you so much, Aisha. So thank you so much for the opportunity to present today. And thanks for the intro. And like Aisha said, I'll be talking about the importance of fire management and research in a large conservation area in South Africa. And I'll namely be talking about Kruger. So when people think of fires, this is how most people see fires, right? They see large-scale devastation, which it does cause, and there is costs involved. And this is particularly true for places where there is this wildland urban interface, right? But this is how we see fires. We being people that use fire as a land management tool in fire-prone landscapes, such as Kruger, which is in the savanna biome. And we see it as being part of the system where there's a sense of renewal, so sort of like the phoenix example that Aisha told us. And there's this regeneration that then happens after fire, where there's this green flush that then starts growing, which is really high in certain nutrients. So animals like congregating, herbivores like eating on this green flush because it's very nutritious grasses. And then just out of interest, this little flower in the bottom left is from the fynbos region of South Africa. Which is actually called April Fools. And this particular species of flower only flowers after a fire has gone through the system. So there's clearly a kind of stimulus either in the smoke or in the ash that then gets deposited after a fire that then allows this particular species to germinate afterwards. So when we think of fires globally, fires are an important and natural process in many of the continents around the world. You'll see that this is just a picture of a GIF file of fires during 2014, 2015. And you can see the amount of fires just in Africa itself also. So you'll often hear Africa described as the fire continent for this reason, because many of the biomes, especially in sub-Saharan Africa, are fire prone. So if we think of just in Kruger National Park in South Africa, and specifically, roughly 70% of the country is in one or other fire-prone landscape. Whether it's the fynbos down in the southwestern parts of the country, whether it's the grasslands in the Highveld, the savannas on the eastern bit of the country, a large proportion of the country, fire is a dominant process in the landscape. So with regards to Kruger, just to orientate yourselves, Kruger is in the northeastern region of the country. It's approximately 2 million hectares, so it's very big. And we have the ideal climate in Kruger to support fires. So you have these wet summers where majority of our rainfall falls. Then there's this biomass and fuel load and grasses that grow during this growing season. And then we head into our hot, dry winters that have the perfect weather conditions that then support fires to burn. And fires are a key abiotic factor influencing ecosystem processes in our savannas. And savanna fires can be ignited either by people, sometimes this is by accident, sometimes on purpose. These can be management fires, for example, that we put in ourselves, or naturally caused fires caused by lightning. Lightning fires are, however, less common and they often do not burn through large parts of the landscape. This little GIF file over here is just some imagery of the kind of fires that we get in the central region of Kruger National Park around the Satara area, for those of you that might know the park. So on average, roughly 5% of Kruger burns every year. That doesn't sound a lot, but because of the size of the park, that's about 100,000 hectares. And just out of interest, our previous fire season in 2021-2022, we had really high fuel loads because we received a lot of rain before that dry season started. So we had roughly 20% or 400,000 hectares of Kruger burning. And if many of you guys have been following the media recently, you would have known that also now during the month of February, we also had a lot of rain falling. So our grass loads have accumulated more than it usually does. So we're also anticipating more fires this year and might very well also be around 20%, if not more, that we might have in the coming fire season. And this is just fire scar map. So we map our fires every year in Kruger. This is how it looked during that time. We had 400,000 hectares in Kruger burning. The gray bits is Kruger. The not gray bits on the eastern boundary, that's Limpopo National Park in Mozambique. And then these other bits on the western boundary are some of the private nature reserves on the western boundary of the park. So we're even able to map some of the fires as well because it's done with satellite imagery. And then just to understand how fires and rainfall are so related, basically, depending on the amount of rainfall you get, you have tree production, you have grass production, which then increases your tree and grass biomass, right? But you have browsers that will eat on your trees and your woody vegetation. You have grazers that eat on your grasses, but you have fire that can consume both trees and grasses. So you will often also hear sometimes people refer to fire as being a generalist herbivore because it can eat both trees and grasses. What's quite important to note also is this feedback between grass biomass and fires, because in our landscape, the amount of fires that we have is directly related to the amount of grasses that we have. So to put that in imagery, if you look on the left, that's after good rainfall, right? So sort of what we had when we had 20% of Kruger burning. We had lots of rain, lots of grasses accumulated. So in the dry season, in a year like that, you can have a fire burn through that landscape. However, if you have poor rainfall years, so like during the drought, this particular image was taken during our 2015-2016 drought. And you can see there's basically no biomass that could be burnt, right? So whether you have herbivores that consume all the grasses or you have drought years, you cannot have a fire burn through the landscape in years like that. So Kruger fires need grasses to burn. So a break in fuel continuity will limit the fire from spreading. So in this image below, you can actually see that we have clumps of grasses. Those are the only kinds of fuel that will burn. But once it hits mineral soil, there's no fuel for it to burn. So then the fire cannot spread. So this was also what Aisha was talking about in the introduction, but these are the three main elements you need to have a fire. And then you get different types of fires. So in Kruger, our fires is what we call surface fires. And basically what this refers to is, let's go back, sorry. Basically what this refers to is grass fires. So our fires burn across the earth's surface, across the land surface, just in the grass layer. Then you get some areas around the world, so like the pine areas, the tundras, those parts of the world where they have these large tall trees, they get crown fires. Even in Australia, in the eucalypt forest, they also get what they call crown fires. So these are when fires climb up through the bark into the canopies of the trees, and it burns all the way up. And these flame heights can be really, really high. Like you're talking about our grass fires, we might have flame heights of only like 4 meters or so, but a crown fire, depending on how tall some of these trees are, could be 50 meters, for example. And these are fires that burn in the treetops. These are very, very hot fires, very difficult to fight and control as well. And then another type of fire that you get in places where there are peatlands, so like areas like Indonesia, some heathlands in the UK, for example, even in Canada. So places where there are peatlands, you get what's called ground fires. And basically what this means is they also refer to this as zombie fires, because where there's these high carbon substrates, these fires burn through that carbon below the ground. So you don't see the flame above ground, but below ground, it is actually burning. And they are extremely difficult to extinguish and control because it is difficult to actually get water or anything to extinguish it. So sometimes you can have these fires burn for months on end, just burning below the ground. And then sometimes what happens is, depending on the weather conditions and the fuel above ground, those ground fires can then surface and cause the above ground fuel to then start burning as well. But we don't have those kinds of fires in South Africa. So with regards to elephants and fires, there's a very interesting interaction between these two very dominant drivers in landscapes such as savannas. And what I mean by that is that the bark in the savanna trees are thick, so they're able to withstand heat from fires. But when a tree is debarked by an elephant, it then becomes vulnerable to the heat of that fire. So for example, these are the two Terminalia sericea trees. They're often not eaten by elephants, but in this case, the one tree was debarked. And this was the exact same fire. These two trees of the exact same species, same height, same width of the stem as well, were about 3 or 5 meters apart. But the only difference is one was not debarked on the left, and the other one was debarked. And you can see on the left, the fire did scorch the bark a bit, but then it just died off after that. Whereas the one that was debarked, the heat of that fire was able to penetrate into the inner cambium of the tree. So it was then vulnerable. So the thick bark is almost like a thick blanket that sort of protects it from the fire, but once that's removed, it is then vulnerable to this fire. So if you put it in a sequence, this is a marula tree, which elephants love eating. That's like elephant ice cream. They then eat the bark, especially during the dry season where there's not much grasses around. They debark these large marula trees. Nigrescens as well, Acacia nigrescens, Senegalia nigrescens. They debark those as well. So then once a fire moves through the landscape and burns into that, and successive fires eventually burn, it can eventually kill the tree, and then the tree will succumb to a fire because the elephant had compromised it before that. So this is just some imagery from the northwestern boundary of the park, where you can see on the right-hand side, this is inside Kruger. So we have both fires, we have elephants. This is on the other side of the fence where there are still community members and villagers, and they use fires for land management purposes, for clearing lands, for opening land for crop, etc. And also just to provide green grazing for livestock and cattle, but there are no elephants. So you can see the stark difference in vegetation structure just when you pull out one of the two drivers, in this case being elephants. And in this image, this is from our fire experiment up in Sitare in the central region of the park. I'll talk a bit more about this fire experiment a bit later. But on the left-hand side, this is where we have fires that burn every 2 years in August. So it's a hot fire, fairly frequent fire. And it's also open to elephants because it's not a fenced-off area. And then on the right-hand side, this is the control plot or the no-burn plot where fires have been kept out since the 1950s. And once again, you can see if you pull just the one driver out of the equation, what impact that then also has on vegetation structure. It also has an impact on vegetation species composition, but you can't quite see that from the imagery. So reasons for burning, there's many reasons why people burn. We burn in Kruger to promote fire's ecological role. This has been well studied to show how important fires are in the savanna landscape. Research and experimental fires, we do a lot of this in Kruger. Kruger has a rich history of research in general, but also fire-related research. And the experimental burn plots I'll talk about a bit later is nearly 70 years old, is this experiment already. So we burn roughly almost like 100 fires a year. And then there's also safety requirements. So this is based on national law, where as a landowner in a fire-prone landscape, it's your responsibility to make sure that you put in what's called fire breaks, right? Around your property, you construct these fire breaks before every dry season or fire season. And that limits the risk of, if there's a fire on your property, that fire jumping into your neighbor's property. And likewise, if your neighbor has a fire, it limits the risk of that fire jumping into your property. So it's important that we're part of what is called a fire protection association, which Kruger is part of. Us and some of those Western private nature reserves, we're all part of the same fire protection association. And this is based on the National Forest Fire Act of 1998. And it basically aims just to govern and guide the use of fire as a management tool, and to reduce and mitigate the risk of wildfires. So this is really useful in the sense that, you know, if there's a need for additional resources to fight a fire, we're able to actually share resources and expertise amongst neighboring landowners to actually use fires in a responsible manner. And if there is a wildfire, to get the fire under control. So now I'm going to get a bit into the evolution of Kruger's fire management policy. So Kruger was proclaimed in 1926, so it's almost 100 years old. And because fires have been part of this landscape, over the decades, we have had to adapt our fire management policy based on the best available knowledge at the time. So I'll start in 1926, and for the first 2 decades or so, there was a very what we call laissez-faire, relaxed attitude towards fire management. And Stevenson Hamilton was the first park warden. He came from the military, so he had a military background. And when he came in, he placed a general ban on any deliberate burning in the park because he thought it was bad and had a negative impact on vegetation and wildlife. And then roughly 10 years later, he had a complete philosophical change, and he then suggested that the bush should actually be burned every second year. So he then realized that, you know, fires are useful for providing for green grazing for herbivores, and that it prevents this accumulation of what we call moribund material, which is that dead, grassy material that sits above the soil surface that nothing can eat, and it's highly flammable. So if you have fires frequently enough, it burns away that material and it provides for green grazing. And then if we also think about humans and fires in this landscape, right? Anthropogenic fires have been used in Africa for roughly 1.5 million years. And in Southern Africa, humans have been using fires to manipulate the environment for roughly 55,000 years. So this would have been for farming purposes, to cycle nutrients, because people would have realized that when areas burn, there's very nutritious grasses that then regrow in this area, which is great for livestock. And then you can also control herbivore movement to facilitate easy hunting. So you know that animals are going to follow these recently burnt areas as the vegetation starts recovering. So there's a way of controlling herbivore movement to facilitate easy hunting. And then just out of interest, early Portuguese explorers referred to the interior of Southern Africa as Terra dos Fomos, meaning land of fire and smoke. So as they came around the tip of Africa many centuries ago, there was always just fire and smoke. And in this map over here is basically evidence of human settlements in the park. So you can see humans being a very important ignition source for fires in the landscape. You can see that where people were, there would have been fires as well. So these are grave sites, sacred sites, ruins, etc., just showing how humans have dotted this landscape for a very long time. So if you look at after those 20 or so years of very relaxed attitudes towards fire management, we then went into what we call a fire protection era. This was when they then realized in 1948, no, fires are bad. So now there was this concern about perceived negative effects of fire on grazing and soil erosion. But this had coincided with a national law on soils, actually. That was called the Soil Conservation Act in 1946. And there was this idea that in order to conserve soils, and fires are bad for soils, we need to stop. They needed to actually place a ban on any prescribed burning anywhere in the country. And if you were found burning on your land, the land could be taken away from you. So they were very strict about it because they were trying to drive agriculture back in the 1950s. And then just out of interest, this was our second park warden, who also came from a military background. And this is just a quote that he was minuted as saying, where he says, "I am convinced that the past policy of burning has caused a change for the worse in our vegetation, and that this change has had a profound influence on the distribution and breeding rate of wildlife in the park. Deliberate burning in an area which must be kept natural must cause an upset to any natural balance. So that was his perception of how fires were having a negative effect on the savanna biome. So then, of course, Kruger, we also didn't have any prescribed burning. So we tried for that roughly almost 10 years to have no fires in Kruger. But of course, there were some emerging issues, one of which was the fact that we only had 8 ranges in Kruger responsible for 250,000 hectares each. That's a massive area to maintain and to try to extinguish a fire. To even see a fire over an area of 250,000 hectares is extremely difficult. So of course, it was nearly impossible to implement. And on average, 20% of Kruger was still burning every year at the time where they wanted to completely keep fires out of this landscape. So it was extremely hard. And if you look at fire extent, which is hectares, how much land in Kruger was burning over these many different years, this so-called fire suppression area that we went through, you can see there was 1 year where almost half of Kruger burned down. So every year there was still a fire in this landscape and they couldn't keep fires out of it. So then we went into a fixed prescribed burning. So this was after they then realized that fires are part of this landscape, but there's been part of this landscape for thousands of years. And it has an important role to play on ecosystem health and maintaining the savannas as we know it. And now these savannas have co-evolved with fires in the landscape. So then the park basically put in some fire breaks and created all sorts of blocks, roughly 400 blocks across the park, so that these fires could be applied every 3 years after the first spring rains. So this is around November, December, maybe October if the rains came early. So there's a very fixed prescribed burning. Each one of these 400 blocks would be burnt once every 3 years. Emerging issues, there was a change in grass composition. So there were some parts of the park which then, in retrospect, we realized that they were burning too frequent. They should not have been burnt every 3 years. So what happened is you ended up increasing your unpalatable grass species that are fire-driven. So they do really well when they are burnt frequently, whereas the more palatable grass species needs less fire in that landscape. So then there was a change in grass composition. That was the one problem. The other problem was the technique in which these fires were being applied, namely called ring burning, which is a technique in which all those fire fronts are lit at once and then the fires then converge. So you then have areas in the middle of that block which then gets extremely hot as these fires meet. And then just this general lack of variation with having such a fixed cycle. Kruger in general is a very heterogeneous park. The landscape is very heterogeneous, and now you sit with such a very fixed cycle in a very heterogeneous landscape. This is also one of our fires in the Sutare area of the park, one of our experimental fires. Then we went into a flexible prescribed burning. So they still kept the 3-year season. They changed the season. So what happens if you burn July, August, when it's hot and dry and you get high intensity fires? What happens if you burn December, January, when the grasses are a bit greener and your fires are a bit cooler? So they wanted to have the seasonal variation as well. Then we went into 10 years with a complete philosophical change again, where they thought, no, you should only allow for lightning fires because these are the natural conditions under which the biota evolved. So the park tried that as well. And then when we looked at, during that 10-year period, how much of Kruger was actually burning with lightning-caused fires, so these are the yellow bars, versus all other ignition sources. And you can see still majority of the fires in this landscape were other ignition sources, namely humans. So yeah, this is just another graph illustrating that you can see there were still a lot of fires with the black bars, which were the unscheduled, unplanned fires, because they only wanted to allow for lightning fires. Then in 2001, we then went into an integrated fire management policy. We wanted to manage for combined ignition sources and have seasonal variation. So fires could be put in by park management. We would account for lightning fires, and we would also account for fires started by other people walking through the park. There was a civil war in Mozambique during that time. So people were walking through the park as well, and also would have lit fires along the way. So we wanted to account and try to manage for all these possible ignition sources. Then we would determine the amount to burn. So how much fuel is there available to burn based on rainfall estimates and biomass available in the veld. And then the ranges would determine where and under which weather conditions they would burn. So that you could have some heterogeneity in where these fires were applied and under which weather conditions. In 2013, same thing, we kept our integrated fire management policy. Our amount to burn is calculated on preceding rainfall. There are different fire management zones that indicate what type of fire you want where in the park. So I'll get a bit into that shortly, so that there's not one blanket management approach for the whole of 2 million hectares. Then the rangers would determine where in each of those fire management zones he or she would burn. And then in 2019, we updated it again. So it's kept very much similar to the previous one. We just updating the use of our satellite imagery to Sentinel, because Sentinel is a lot more accurate compared to modus that we used to use in the early 2000s for fire mapping. And then we're including burns for anti-poaching reasons. And then to consider those fire-elephant interactions that I been mentioned earlier. So what we did is, when we made these fire management zones, we took into account the rainfall, because we understood the relationship between rainfall and amount to burn. We took into account the geology and the soil differences, because the vegetation is also different according to the soils. And then we looked at fire frequency over a 67-year period. So we were able to see historically over nearly 7 decades where fire's been burning a lot in Kruger and which parts of Kruger generally don't get a lot of fire, so that you don't go put a fire every 3 years in a part of the park that should only burn once every 15 years, for example. And then we came up with this, right? These are fire management zones. So you can see there's some parts of the park, like down here in the southwestern parts around Pretoria, Skulpstol's Neck, where historically there's been lots of fires, intense fires in this part of the park. And also that there's a certain ecological objective we want to achieve using fire. So in this case, there was the concern about grazing quality. So the kind of grasses in this area is not very palatable, but once an area is burnt, herbivores then congregate there, and then they would eat on that kind of those kinds of grasses. And then also we wanted to combat bush thickening, which with a certain fire regime, you can actually meet that, where you can actually control your bush thickening in this part of the park. Then there's other zones like the blue ones on the eastern boundary of the park. Here we think historically, with all those different decades, with all the different burning that we used to do, there we've burned too much and too hot. And our ecological concern here is that there was this increase in unpalatable grass species that I mentioned earlier. So these are some grass species like Bothrocloa radicans, which no herbivore wants to eat. It's really yucky grasses, but they do really well with fires. There are certain tannins in it that just makes the fire spread nicely. So it's to their advantage when a fire comes through there, because they can outcompete other grass species. And then the other ecological concern is the loss of tall trees. So there are certain tall trees in this landscape. So like certain, like our leadwoods, for example, our Senegali and aggressants. These are species that they assumed were not able to cope with such frequent and such hot fires. So now what we're trying to do is we use early season fires. So just as we start heading into our dry season, and then the fires are a lot cooler. They're not so hot, and then they also burn less frequently. And then lastly, just these yellow bits over here, these are around our rivers. This is the Sabi, the Olifants, the Letaba, the Lebubu, and Limpopo River. These areas historically also doesn't have fires. Rivers are like natural fire breaks in the landscape. So here we do not put in any management fires ourselves. But if there is a lightning fire after years of really good rainfall, we will allow that fire to burn to its fullest natural extent and self-extinguish, unless there's a threat to property or lives. The only other fires we would put in places like this is infrastructure and fire breaks around camps and staff quarters, etc. So you can see there's no one fire management for the whole 2 hectares. There's certain parts of the park where we want to burn hot, where we want to burn cool, where we want to burn more, where we want to burn less. It depends on the various ecological objectives we want to achieve. And this is just roughly our fire management loop through the year. And around April, which is next month in my calendar, this is where we calculate our fire targets. So based on the preceding rainfall, there we go. So based on the preceding rainfall, we're able to predict how much fuel is available to burn in various parts of the park. And we then calculate these fire targets, right? So there was a study done which actually showed that the amount of area that's burnt in Kruger is directly related to the mean preceding rainfall we received in the 2 rain seasons before that. Right, so rainfall has a direct effect on area burnt in Kruger. So once you say, okay, Pretoria Scope, you have so many hectares to burn, Olifants, you have so many hectares, Punta Maria, Pafuri, etc. This is how much you have to burn. The rangers then apply these prescribed burns on the ground based on the various targets for various parts of the park throughout the year. And then this is just a little GIF of fires in Kruger, and you can see there's certain years. So every year there's a fire in Kruger, except we'll wait for 2016. 2016, there were no fires, and that was because of the drought. So you can see there's certain years over this like 20-year period where there's lots of fires. So fires are very, very prominent in this park. And a lot of this are management applied fires. Then each time these fires are burnt, each fire gets reported. So every time there's a fire on the ground, the rangers will fill in a fire incident report, notify us where these fires are, and we map the fires using satellite imagery. So this is just a blurry example of a fire incident report, the date, the time, the section, the GPS coordinates for where these fires were, and the fire cause. Was it a management fire, an ecological burn, a lightning fire, fire started by tourists, come in, jump in the, maybe the fire started by power line or came in through our boundaries. These are how we keep track of this. And then this is very important for when we map the fires. So if you look at how we came from hand-drawn maps in the 1940s, they realized back then already how important fires are in the landscape, and they drew their little rough hand-drawn maps to MODIS satellite imagery in the early 2000s, but now we use Sentinel satellite imagery, which is a lot more accurate. MODIS couldn't pick up a fire if it was smaller than a soccer field, where Sentinel can. Sentinel can pick up a fire that's smaller than 20 by 20 meters. So it's really accurate. And also Sentinel is able to pick up cooler fires. So some of those fires that are burnt in the early season when the grasses are still green and they're cooler and they're slow moving, MODIS couldn't necessarily pick those kinds of fires up where Sentinel can. So those fire maps, those fire incident reports are very important for the fire map, because during the time of MODIS, when MODIS wasn't that accurate, sometimes like one of our, let's say it's a very bare patch of soil on the basalts, that reflectance when that soil heats up would be picked up by the satellite as being a fire, when in real life it's actually not a fire. It could just be a dry pan. Or a granitic copy, for example, when it gets really hot on our 40+ days, it gets that hot in Kruger, the satellite will then think that's a fire. So you needed those ground truth reports to actually verify what the satellite is saying. So it's really important to have both in combination. And then after the entire year is finished, we then assess our previous fire season, where we see, okay, these were our targets, these were the kinds of fires we wanted in certain parts of the park. Did we achieve that or not? And we do this on an annual basis every year. So now I'm quickly going to go into our experimental burn plots. So Kruger has a long and rich history of fire-related research, looking at fire effects on vegetation, fire effects on herbivore use of the landscape, fire effects on arthropods, invertebrates, etc. My personal bias and favorite is fire effects on soil properties. That's where I link all these abiotic drivers of hydrology, soils, fires. Yeah, and we're able to do some really cool experiments looking at different emissions as well, with different kinds of fires. So I'm just going to talk so briefly about these experimental burn plots. And as you can see, I don't know if you can see my cursor or not, but there's a bit on the inside of the plot here on the right, which is the actual plot. Then you get these little fire breaks, which is like a gravel road where there's basically mineral soil, so the fire can't spread. And then a burnt fire break that gets burnt every year, and then the rest of the block. So basically the aim behind that is you don't want your fire in your little burn plot to jump and burn down hundreds of hectares of the park. Or likewise, if a ranger is applying a fire in his or her section, that fire shouldn't burn into your experimental burn plot, because your experiment should be burning at very safe treatments. So this is just a map of Kruger once again, and you can see there's many burn plots scattered across the park. It's a long-term fire experiment initiated in 1954. So if you remember, this was during that time where they were banning fires, right? Because they thought fires were bad. So management decided to set up an experiment to actually investigate the role of fires in the savanna landscape. So it was aimed at investigating the influence of different fire frequencies. So what happens if you burn every year, every 2 years, every 3 years, every 6 years, if you don't burn, and different fire seasons. So if you burn in April, when the grasses are still a bit green, what happens if you burn in August, when it's dry? What happens if you burn in October, where it's even sometimes more dry, and the fires are even of a higher intensity? Sometimes the rains come early, so sometimes they can be cool. What happens if you burn in December, etc.? And then they broke it up into the 4 major vegetation types in the park. So so it's also across rainfall gradient. So with high rainfall down in the southwestern parts of the park and decreasing as you head north, and then also on the different geological gradients. So the granites on the west and then the basalts on the east. And this is just some imagery of roughly how these plots look. An annual fire plot, generally open, not too many shrubs, whereas a no fire plot has very long grass and a lot more shrubs, for example. And then the plots itself, because it's an experiment, you need replication for the stats. So if you just zoom into the Pretoria-scope area, right? There's 4 replicates in that landscape on that geological gradient with that rainfall. But in total, we have 208 burn plots of roughly 7 hectares each. So they are massive. They're about 350 hectares by 150 hectares. So it's a really big plot. And they have varying fire frequencies and seasons. So let's zoom in quickly just to Pretoria scope. And if you zoom into one of those 4, which is Shabeni, this is roughly what it looks like on the ground. And each of this is 150 meters by 350 meters. So you can see there's a control plot where fire has been kept out since 1954. There's a plot we burn every year in August, every 2 years in August, every 3rd August. So same time of the year, same season, but the difference is the frequency in which it burns. So the 3-year plot, for example, will have 3 years worth of grass growth versus a plot that only has 1 year's worth of fuel. So you can imagine the intensity will also be different just because of the frequency. And then you can have a plot that burns every 3rd February, every 3rd October, every 3rd August, every 3rd December and April. So the same frequency of fire, but burnt at different times of the year. So there's a lot of different treatments and combination of treatments that you can then experiment with. So with regards to fire application, the way in which fires burn on the ground, right? There's something what we call a backfire. So let's say your wind is blowing in this direction, right? The fires move very slow because they have to burn into that unburnt fuel. So they burn low, they burn slow. The temperature is much lower in these backfires. Whereas if you burn what's called a head fire with the wind, it burns much faster into that unburnt material. The flames are higher, the fire moves much faster. And this is the difference between a head and a backfire. So the kind of data we have on these experimental burn plots dates from the 1950s, even from before the experiment was first put in. But the exact same variables that we collect today when we apply these fires each and every time, is the exact same data sheet even from 1982. So it includes climatic variables. So what's the temperature on the day you burn, the relative humidity, because you can imagine the drier the air, the hotter that fire is going to be. Versus if there's high humidity in the air, the cooler the fire will be. Wind speed, wind direction, this all plays a role. Fuel characteristics, so biomass, your fuel load, how much grass is there to burn. And then your fuel moisture content, that FMC, refers to how green or how dry your grasses are, because that also, like I mentioned earlier, has a big role to play on your intensity. And then fire behavior, rate of spread, how fast is the fire moving over the landscape, the type of fire, head fire, backfire. You calculate your intensity. And then we have our pre and post vegetation data that's also being collected on the burn plots. And then I think might be my last slide. You know, to have such a long fire experiment takes a lot of time and money and investment from the park in order to maintain an almost 70-year-long fire experiment. So it's quite important for us to actually keep track of the value of long-term experiments. So you can see the initial, so this is just per decade. Initially, it was very slow progress. There was little reports and theses and data sets collected. And then in the late 1990s, there was a massive jump in the interest in the experiment because there was with new management, there was concern like, okay, we spend a lot of time and money on this burn plots. So what's coming from it? And then that's when people started publishing a lot more from all those data sets that they had. There was also a lot more researchers and international scientists coming to work on these experimental burn plots. So it's quite interesting to keep track of this. It's almost 2025, so this last bar will be updated soon. But if you look at, let's go back a bit. If you look at the variation in the studies that have been done, we started to just want to know the effect of different frequencies and seasons on vegetation. Then it has morphed into how fires affect animal use of the landscape, insects, invertebrates, birds, small mammals. These are all kinds of studies that have been done. Fire effects on soil properties, which is my personal interest. And then the kind of studies we're able to do today is, which I always say that the people that started this experiment in the 1950s will be mind blown to know that there's certain studies that we can do today because they initiated this experiment almost 70 years ago. One of which is that we're able to look at different fire regimes, different seasons of burn and frequencies on carbon emissions, all kinds of gases emissions as well. And then also with Sentinel, for example, this new satellite imagery and satellites that get launched, they're always developing and improving the fire products on this on these satellites. So we're able to actually, because these fires are planned way in advance, we know exactly where they're going to burn, when they're going to burn, what fuel is burning, how much fuel is burning, etc. So much valuable information, the climatic conditions under which these fires burn, that these guys from the European Space Agency come and work on these experiments, because we can actually time our fires with the satellite overpass to make sure that, to see if those satellites can actually pick up our fires. So, which sounds great, but it's very stressful. It's like a third of a second. If that satellite flies past and your fire was not burning at the right time, you have to wait a couple of days before it comes back. But these are some of the cool experiments that we're able to do today because of such a long-term experiment. So just some acknowledgements: SANParks conservation management and ranges that apply. The majority of the management burns in the park. Technical services that helps with the grading of the fire breaks around the experiment. And then, of course, the scientific services fire team. So these are the girls and guys that I work with to maintain that fire experiment. Thank you.
Sure. Thank you, Tercia. Very well done. Very excellent talk.
Thank you.
I would like to know, but I see you added on the last slide, the scientific fire services.
Yes.
Because I wanted fire services, because I wanted to know. So, I mean, we looked at your bio at the beginning, and it's from the varsity. So I just want to know, like, with the ocean, with marine biology, for example, we have to go for the safety course to learn how to be at sea. So as part of your study, like the more practical part, that is usually not part of a university curriculum. So it goes extra. Do you also have to go for fire training, or
Yeah, so that's what when I speak to people from other parts of the world where they still in the fire suppression part of fire management, and they trying to move towards more proactive prescribed burning, that's often the limitation, is because it costs a lot of money to send all your personnel for training. To equip them, they need the right PPE, the right uniform, the right gloves, mask, everything, because you cannot be just working with fires willy-nilly and not be trained and equipped to actually do that. So yeah, we do need to all go for training. And like my personal journey from the days at UWC to what I do today, I always tell students it's quite interesting. You don't always know where your career is going to take you, because I started out in environmental and water science and geohydrology, and then in my master's into hydrology and soil hydrology, and then getting into the fires. And now I manage fires, and now the PhDs in soil science. So you just never know how your interests change and how your careers might change down the line as well. But yeah, training is important. And then besides training and equipping your personnel, the what we call bakisakis, which are like 600, sometimes 1,000 liter plastic containers that you put at the back of your vehicle. So if you don't necessarily have a fire truck, but there's those kinds of equipment. You need drip torches to light your fires. You need fire beaters. There's a lot of money that's needed to actually fund proactive fire management. Yeah.
Oh, so that's interesting. And then also you spoke about how I didn't write it down, but you spoke about how sometimes you leave the natural fires to, what did you say, consume themselves until they die naturally.
Yeah, to burn it out.
So do the fire breaks like prevent them from going too far, or does it just take care of itself?
Yes. Yeah, so with the fire breaks is important because it helps you manage the fire. Can you imagine if a fire was burning, and a fire can burn, let's say, 1 meter in 3 seconds, right? You can't run after a fire fast enough, right? And imagine it's 2 million hectares of not broken up pieces of land. So because the fire can't burn over mineral soil, it needs fuel. You can remove that fuel layer so that that fire is going to stop. Sometimes it can jump. If conditions are hot enough and dry enough and the fire gets like it's high intensity, it can easily jump that. But it allows you to actually start burning from that point towards the fire so that it meets away from that point so that it doesn't jump the road. So yeah, fire breaks are very important. And then also, so with lightning fires, they were naturally caused, and if there's enough fuel available for the fires to burn, then we allow it to burn to its fullest extent, as long as there's no threat to property and lives. With animals, we must remember that because savannas have co-evolved with fires in this landscape, animals know how to cope with fires in the landscape as well. They can hear the fire approaching fast enough, they can smell the smoke, they can hear the crackling, so they know how to move away from fires. You also get certain animals that will burrow. We've seen animals even just hide behind the stump of a tree or a rock because the fire moves so fast that it's like literally a second or two over them and then it's done. So people always think that with fires there's really high mortality of animals, but that's not really the case. It takes a very, very extreme fire and for animals to be trapped for them to actually succumb to a fire. They know how to deal with fires. What's interesting is that like with certain bird species, right? You get to our experimental burn plots. We get there's a couple of birds here and there. We don't even really notice them. As soon as you start burning and there's some smoke, you'll see your insect eaters start flying in, right? Because they know now the grasshoppers and the other things are going to start jumping away from the fire. Then it's so interesting how they've learned that smoke in the landscape means easy food. So they end up flying to those areas because it's just easy hunting for them. And then later on, once that fire has moved past, you end up seeing your seed eaters. So there's certain doves and stuff because now the seeds are now exposed because now the landscape's now open to all these grass seeds. Certain fruits, etc. They end up seeing this and then they end up eating that. And then later on, you'll get some of your bigger birds, like your Kori bustards and I'm trying to think what are those other ones. Kori bustards. That if there's anything maybe bigger that might have succumbed to it. So maybe like a lizard or a gecko or something. So interesting how there's all these other species that have learned how fires play or are important in this landscape, so they use it to facilitate easy hunting and then they benefit from it.
In my head, I'm seeing them WhatsApping each other to say that they have an opportunity.
A WhatsApp group. Fires 11 o'clock that way.
So I think because I know you answered a lot of the questions that I had as you were going along. I mean, this was very well done. You covered everything. So
thank you.
I think if Cheryl doesn't have a question, then that's a sign that you really covered everything. So
Aisha, may I ask, in the fynbos we have the example of the proteas that are dependent on fire to keep on distributing themselves, and any examples like that in the savanna landscape?
I didn't quite catch that, Johan. Did you say in the fynbos there's certain species that need fire.
The proteas that need fire to germinate their seeds.
Oh, yes. So like that example I showed in the beginning with the April Fools, there's nothing, what's the word? I don't think, unlike in the fynbos where certain species will not exist without fire, I don't think that's the case in the savannas. I think the savannas, the role of fire is more to keep that balance between grasses and trees, right? So like you don't want the place to become overly wooded or closed forest-like. So the fires are there to able to burn through that so that there's still enough areas that are grassy enough, because there's certain species in this landscape that need closed wooded areas, so like bushbuck, for example. And then there's certain species that need your more open landscape, so zebra, wildebeest. So that I think the fires are there more to just keep that intricate balance between trees and grasses aligned. Yeah, and that play.
Interesting. Well, you've proven that birds of prey are real South Africans because they gather where there's a braai. So that's my contribution for today. Thank you very much. Brilliant talk.
Thank you, Johan.
Brilliant.
I think on that topic that Johan was talking about birds of prey, just out of interest, there's birds of prey in Australia that were also found to actually pick up burning twigs. Because remember, Australia is also a very fire-prone continent. And they were found to pick up burning twigs from areas that's burning and drop them in unburnt areas so that it would help the fire spread, because the rodents and things would run out. So then the black, the brown kites, I can't remember what, it was like 3 species or so that really actually all benefited from just helping the fire spread. So that would help the fire spread across the landscape, because then it was just easy hunting for them. So I think that just further proves how old fires are in this landscape for animals to know how to benefit from it.
Sure. So what do you think will happen if the humans are removed? Will there be a change in the ecosystem? Will they then start causing fires, especially the birds? For themselves.
For sure. I mean, you know, I think it's quite important that, and that's why I like talking about humans and fires in the landscape as well, because we often exclude ourselves as if we're not part of the ecosystem. We are, and we have been since we've been on Earth. You know, we've been part of the drivers of ecosystems, and we are one of the ignition sources in the landscape. And, you know, when you think of global change, you know, you often, like if it's in the news, in the media, when they talk about climate change and global change, they always show imagery of fires burning. And it's almost as if it paints this idea that fires are causing climate change. Whereas what's the biggest issue here is rather that, I mean, we know the fires have been on this planet for millions of years, and there's always been a balance between fires. And so if you think of carbon, I'm talking about too many subjects at the same time, but if you think of carbon, we've been monitoring carbon fluxes in Kruger for the last 20 or so years, and basically the savannas is carbon neutral, right? So the amount of carbons emitted during these fires gets taken up again when those green grasses and the plants recover. They take carbon out of the atmosphere again during photosynthesis when they're growing. So it's considered carbon neutral. Yeah. But with climate change, you know, if we're going to have more hotter days, drier weather conditions, you might just change your fire regime. So fires are burnt in this landscape in a certain way, at a certain intensity, but now with globally warmed futures, we might have even more intense fires than what we've ever had before. So that's more that wildfires could feel the consequence of climate change as well. And we don't know what effect those kinds of fires are going to have on the ecosystem in future, because we're dealing with a globally warmed ecosystem.
Yeah, that's scary. And the future's here, no? It's like approaching really fast. Recently in the news, so wasn't there a hurricane? Was Freddy, wasn't it that side of the world?
Yeah, it was just north of Kruger, more like Zimbabwe up towards Malawi, and obviously Mozambique got hit as well.
Okay. Yeah. No, I just want to know, doesn't it soak the land and then the fires can't start, or what? Does it?
Yes, but there will still be fires. So because once we go into the dry season, so our fires are very different to the fires you'll get in Cape Town. Cape Town, you get fires like this time of the year, summer. Our fires we get in winter when it's dry. So this is like June, July, August, September. So because we got so much rain now because of the cyclone, even before the cyclone, we had a massive cut-off low sitting over the southeast of the country. So we had lots of rainfall. So there's lots of grasses that grew, like even more biomass accumulated than normal. So once we get into our dry season, there's a lot more fuel, dry fuel to be. So we do anticipate more fires this coming year. So we definitely gonna have to be a lot more proactive, prescribed burning so that you limit that risk of crazy big hot wildfires late in the season. So you have to be a lot more proactive with how you manage fires. Yeah.
Okay, so I understand. So it was hurricane. What is it?
It was a cyclone. Yeah.
Okay, so the cyclone comes, the cyclone saturates the soil, but then the grasses grow, and then later on in the season,
When they
there's enough fuel now. Okay, I understand.
Yeah.
Sure. But then if it's out of the rainy season, then it's more because of human caused fires, anthropogenic fires, not the lightning.
Yeah. So the lightning fires will start just as the wet season starts. So that's like at the end of the dry season when things are very, very dry. You sometimes get what's called dry thunderstorms. So you'll get the thunder and the lightning, but then the rain doesn't really arrive. So yeah, that's the time of the year where we generally get lightning caused fires. Yeah. But I didn't show the map in this presentation, but there is colleagues from the Netherlands who's actually mapping the distribution of human anthropogenic fires versus lightning caused fires. And basically the parts that get majority lightning fires is the tundra. So up North America, North Europe, that band of the planet gets a lot of lightning fires. Where majority of the fires all over the world, human-induced fires is, which makes sense. We're part of the landscape, are an ignition source, and particularly in Africa.
Yeah. Okay. Well, thank you so much. I don't see any questions in the chat, but we'll send it to you. Thank you very much.
Thank you. Thanks so much for the opportunity, guys. Cheers.
No, thank you.